Today we want to discuss for the topic 7, gravitation. For subtopic 7.1, gravitational force and field strength. State and use the Newton's law of gravitation. Define and use gravitational field strength. And 7.2, gravitational potential energy. So we need to define gravitational potential energy. And the last subtopic 7.3, satellite motion in a circular orbit. You need to derive and use escape velocity. Derive and use equation for satellite motion. First, velocity and period. Next, related to the equation, list of selected formula. So for this topic, so actually we have a few equations related to the gravitation. First, gravitational force, F equal to G, capital M, M over R square. Next, gravitational field strength, gravitational potential energy, 21, escape velocity, 22, velocity of satellite, 23, period of satellite. Now, look at the symbol of small r and capital R. So look at this symbol, this one, referring to the small r symbols there. So R is a distance from center of object or planet. And then look at the capital R symbol here for the escape velocity. So R here is Earth's radius. Now, look at the list of selected constant value. So for this topic, so we emphasize on gravitational constant is a capital G. So the value is alright. Now look at the gravitation. We need to study for the Newton's law of gravitation, gravitational field strength, gravitational potential energy, and last subtopic is satellite motion. Alright, so now for the 7.1, gravitational force, the symbol is Fg, and the field strength, the symbol is Ag. Now, we need to know that what is a difference between capital M and the small m. So, capital M is referred to the mass of giant planet, such as Earth, Sun. And then for the symbol of small m, refer to the mass of the small planet, or sometimes we call as a test mass. And then be careful here, we need to measure or calculate for the distance we take from the center. So this is the center of the first mass to the center of the second mass. This is actually R. Alright, so next, Newton's law of gravitation. A magnitude of attractive force between 2 point masses directly proportional to the product of their masses, inversely proportional to the square of the distance between them. So we can write in terms mathematically. So Fg is actually the attractive force directly proportional to the product of their masses, inversely proportional to the square of the distance between them. So this is the formula to calculate gravitational force. And then gravitational force in SI unit Newton, and the force is vector quantity. Look at the gravitational field strength. So gravitational field strength, the symbol is Ag. Sometimes we call as a gravitational acceleration. So we know that for the gravitational acceleration on Earth's surface, so the value is 9.81 meter per second square. What is a gravitational field strength? Gravitational field strength is the gravitational force per unit mass. So look at the equation here. Next, SI unit for the gravitational field strength in meter per second square or Newton per kg. So how we can use Newton per kg? So from here, so we know that for the gravitational force in Newton per mass in kg. So therefore, other units for the gravitational field strength in Newton per kg. And then we know that gravitational field strength is a vector quantity. Alright. For the subtopic 7.2 is a gravitational potential energy, and the symbol is U. Gravitational potential energy is the work done by an external force in bringing a test mass from infinity to a point per unit test mass. So look at the equation here. So be careful, for the symbol of capital M is Earth's mass, and for the symbol of small m refer to the test mass. For the gravitational potential energy, the unit in joule. Okay, next. For the last subtopic 7.3 is a satellite motion in circular orbits. Referring to this diagram, so we can see here the gravitational force actually toward the center of circle. Meaning, we consider the concept of centripetal force. Refer to the concept, gravitational force equal to the centripetal force. So using the equation of gravitational force equal to the centripetal force. So M here refer to the mass of the net. And then therefore, we can determine from the concept the equation of velocity of satellite. Be careful here. So R here must be distant from the center of the satellite. Okay, look at this diagram. from the center of satellite to the center of the Earth. This is the R. Okay, next, escape velocity. So the equation is, and then make sure the symbol of capital R here is, and the unit in meter per second. Alright, so next we have the linear velocity. For the linear velocity, the formula is, and the unit in meter per second. For the period T, the equation is, and then in unit second. From this topic, so we have the conclusion here. So for the capital M here, make sure the mass of big planet. For the symbol of small m is a test mass or smaller planet. The small r here distance from center of first object to the second object. And the R, capital R, is Earth's radius. Thank you.